In this video, I'm going to be covering Gibbs Free Energy. Gibbs Free Energy can be denoted with delta G. The Gibbs Free Energy for a given reaction is the energy associated with a reaction that is able to do work. So what does this mean? So if we have a reaction, A goes to B, and say we are at equilibrium in this reaction. So we can have a couple different delta G values for this reaction. If delta G for this reaction is positive, that means that this reaction needs a positive amount of energy in order for it to run. So in other words, in order for this reaction to proceed, there needs to be an external source of energy put in to A in order for it to go to B. So what we can say is that this reaction is not spontaneous. Essentially, when the Gibbs free energy value for a reaction or the delta G for that reaction is greater than 0, that indicates that this is a non-spontaneous reaction because we need to put in that amount of energy to do work for this reaction in order for it to run. Now, what happens if we have the same reaction and the delta G is negative? Energy is released. When this reaction runs. So for this reaction, delta G is less than 0. A negative amount of energy needs to be put in order for this reaction to run. So we can actually think of it as, in order for this reaction to run, we will actually release that much energy when we go from A to B. So what we can say is that this reaction is happening. You do not need to put in an external source of energy in order to run this reaction. It can happen on its own. So a ball rolling down a hill without us even touching it is an example of a reaction that would have a delta G value less than 0. That is energy that is released. We do not need to put in a positive amount of energy like we saw in this reaction. So this will be a spontaneous reaction. And if we have A going to B and delta G is equal to 0, we could say that this reaction is at equilibrium. So to summarize, when delta G is greater than 0, we know that this is not spontaneous. Energy needs to be put in. When delta G is less than 0, this is a spontaneous reaction. No energy required. We actually release energy. And when delta G is equal to 0, we are at equilibrium. So using delta G will be very helpful when we work with chemical reactions to decide whether that reaction is going to proceed spontaneously or not.